Hi, this is Mrs. May. Today we're going to look at special systems where in the past we have looked at systems by graphing to come up with one solution. We've done substitution where you come up with one solution, elimination where you come up with one solution, and today we're going to look at systems where there might be no solutions. So as we're looking here, there are some definitions and some things that you'll want to write down. An inconsistent system has no solutions. It's not consistent, no solutions. They also have, if you were to graph these, they would be lines that never cross. They have parallel lines on a graph. And then consistent, meaning they have the same exact line. So you have two equations, but when you go to graph those equations, they end up on the same line on your graph. So two different vocabulary words here, consistent and inconsistent. So we've looked at one solution. This is something we've been doing, looking at systems of equations where there's been one solution, one coordinate point. We've had no solutions yet. We haven't done that yet. We're going to be doing that, where maybe if you graph those, they end up with parallel lines, and then an infinite number solution. So you've got this line on your graph, and then you go to graph your second equation, and it's right on top of it. So that is an infinite number of solutions. Every coordinate point, every number that is on that line matches. And in this case, or is part of the solution set, and in this case, parallel lines, they never cross. They have nothing in common. They have no numbers that would match, and therefore they don't have any solutions. So just taking a look at an example of a system that doesn't have any solutions and how you can show that. You can certainly graph to see if you have a solution or not. That would indicate, are they parallel? Do they cross? If they don't cross, and they don't have the same line, then they have no solutions. You can use substitution, and you can certainly use elimination. This equation is already set up in a y equals, so I'm going to use substitution in this example for you. So when I substitute, it says y equals, I'm going to substitute this portion into here where it says what y is equal to. So when I do that, if you will remember, we substitute for y. We've got negative x plus 5 because we see that y is equal to that. Is equal to negative 2. So when I go to solve this, don't forget you can use the associative property of addition. And so when we do that, we move, we have this x. We've got this, we can move these parentheses around so it looks like this. What happens is x plus a negative x is 0. And it actually eliminated one of the variables, and we ended up with a 5 is equal to negative 2. This is not a true statement. This is not equal. So what happens is this is telling you that these systems of equations have parallel lines and they do not intersect, so they do not have a solution. So these two equations here have no solutions where they have an intersection point. An infinite solution. This one is set up not too badly. If you look here, we've got a 3y. I can easily turn it into a negative 3y by multiplying by negative 3 and coming up with a new equation. We've got negative 3 times a negative 2x is a positive 6x. A negative 3 plus or times a y is a negative 3y. A negative 3 times a negative 4 makes it a positive 12. And if you remember, when we do elimination, we add these equations together. So we've got negative 6x plus 6x is 0, plus 3y plus a negative 3y is 0. A negative 12 plus 12 is 0. We end up with 0 equals 0. When you have this equation, that is a true statement. 0 is equal to 0. That tells you you have an infinite number of solutions. So these two lines, if you were to graph these, would be on the same exact line. And again, you can do this by graphing. You don't have to do this by substitution or elimination, but that is one way to do it. And then the last one is looking at one solution. Now, these are the things that we have been doing when we've been doing elimination, graphing, and substitution, is finding just one solution. So what I'm going to do, I'm going to do elimination again, because it looks like I could easily set up these y's by multiplying by a -2. So if I'm just going to write it down here. We've got this original equation, 5x minus 2y equals 6. I'll put that down here. So when I use the distributive property, I've got -2 times x, it's -2x. A -2 times a negative y is a positive 2y. And 0 times anything, of course, is 0. So now process of elimination says, okay, I've got 5x plus a -2x, that's 3x. This is now gone, equals 6. X is equal to 2, obviously by dividing the 3 out. I have the solution for x, which is 2. And if you remember, when you have one of the coordinate points, you can simply put that number back into either of the equations. This here is x is equal to 2. So we're going to put it in this first one to begin with. So if x is equal to 2, 2 minus y equals 0. Obviously, y is equal to 2 as well. Because 2 minus 2 is equal to 0. 2 minus 2 equals 0. It makes sense that we have this 2 here. So when we substitute back into the second equation, because remember we always double check using that second equation, substituting in 2 for x, we've got 5 times 2 minus 2 times 2 for y equal to 6. 10 minus 4, yeah, that does equal 6. That does check. So we have one solution, one point on the graph, that x and y point where it crosses, of 2 and 2. And so if you were graphing, this is where that intersection point is. Your homework is going to be lesson 7-5 when you come into class. But I would like you to see if you can come up with example problems. So if you can do some example problems, see if you can come up with some examples or samples of each of these. Or even if you write a couple of equations and say, you know what, I wrote a couple of equations, but they both ended up with one solution. Or I wrote a couple of, but they had no solution. Or I wrote a couple and they had infinite solutions. So I want you to give this a try, see what you can come back with. And in class, we're going to put your sample problems up on the board and see if the rest of the class comes up with the same answers that you did, as far as whether it had one solution, no solution, or infinite solutions. Thank you for watching.